The implementation of an electrical diagnostic strategy is very important in electrical work. As said before, the detection of opens and shorts is actually the main procedure that you will actually be implementing. In this next example, we see how an open in the ground side and how we actually, by doing a voltage drop across the actual ground line, feeding the actual module or computer, we can actually determine if we indeed have an open ground. And as we said before, a voltage drop across an actual straight through conductor should be very low or very close to zero, with 20 millivolts on the max side and 0.1 or 0.2 millivolts on the low side. In our example, we see how our meter actually reads 12.6 volts, or actual voltage, supply voltage. This indicates an open circuit, which actually a dead open right in at the ground line, since we are actually measuring between pin number 10 of the actual computer or module right at the computer connector and the actual chassis ground. In this particular case, the actual procedure in order to prove that we are actually missing a ground will be to run a wire, a straight through wire between pin number 10 and battery negative or ground. This will immediately restore the ground going to the actual module, and all the functions or operations are related to this module should immediately come back. Remember that what you are actually doing in this case is performing a voltage drop test at the actual connector or a wire that goes all the way from the negative side of the battery or the chassis ground. It may be at the engine block, it may be at the chassis, or right at the battery. Wherever that ground goes to from the actual computer, actually in between that and the actual pin number 10, which is the actual ground going into the actual module. Since you are taking the voltage drop between these 2 points, this is supposed to be a straight through conductor. You're not supposed to have any resistance there. In our case, we have an open circuit. An open circuit acts as a resistor, actually a resistor of infinite resistance, and maximum supply voltage is actually going to be seen in this particular case. This works well with any straight through conductor. Whenever trying to do a voltage drop to determine whether you have a broken wire, simply going between the 2 points at which the wire is actually supposed to be connected, whether it's a positive, negative, or even a signal wire. This is actually an alternative to performing a continuity test, which will be another type of test that you could actually implement in order to determine whether you have a broken wire. For the most part, whenever you are doing a voltage drop on a ground line that actually feeds a computer, you could also use the actual graphing multimeter, as we'll see later on. And remember that there's a specific value that you are looking for, not higher than 100 millivolts with the engine running, or between 3 to 500 millivolts with the engine cranking. But just simply remember that you are supposed to do the voltage drop test between the 2 points to which this line is supposed to be connected to. In this case, we see that our pin number 10 is supposed to be connected straight through to the actual chassis ground. And we've created the actual opening in the diagram to help you understand the principle. But just remember that just doing the voltage drop, you simply do the voltage test across these 2 points, and you'll immediately know if you have close to supply line, you have an open circuit. You should have very close to 0 volts, and indicating that there is no opens in the circuit. A derivative of this test is actually using the graphing multimeter or the oscilloscope and actually performing the same voltage drop test between chassis ground and pin number 10, which is the ground input to the module. Remember, you are supposed to see nothing higher than 100 millivolts with the engine idling or running, and nothing higher than between 3 to 500 millivolts or half a volt with the engine cranking. The reason for this is that when the engine is cranking, excessive amount of amperage is drawn through the actual battery cables, because you have to run the starter, and this will actually show up as a higher voltage drop across any ground line because of the stress involved. Again, what you're looking for, again, and this the test is actually allowable whenever you are testing any ground line for any module, not just an ECM. And again, it's 100 millivolts with the engine running, and between 3 to 500 millivolts with the engine cranking. An open circuit would immediately show up as actually you will see battery voltage, as we saw before when using the regular volt ohm meter. But however, sometimes you do develop certain resistance spots in the ground, corroded wires, sulfated connectors, and so on and so forth. And this may not show up readily whenever you are actually measuring or doing the voltage drop.